All right, so thanks, Steven. Hi, everyone. This is Danil Zburivsky with Pythian. So today we'll talk a little bit more about how Pythian sees the evolution of traditional warehousing to a more modern kind of data platform approach, and we'll talk about what trends we see in industry and what are the solutions that we think would be that industry will be implementing over the next several years. So Pythian has been in the data business for about 20 years now, and my group specifically was working with building big data platforms on top of Hadoop and other distributed systems for the last 5-6 years. And over the course of this time, we have noticed that there are definite trends that our customers want to explore, and there are different drivers of why people choose to migrate from their traditional warehouses to a more modern or more robust platforms. And this year we have kind of distilled all those expertise that we have acquired over the years, and it resulted in what we call analytics as a service product. And that's basically a result of our experience in building and helping customers migrate from traditional platforms into the more advanced solutions. And today we'll talk more about what those trends are and what those solutions might look like for you in the future. So one of the top requests that we get from our customers right now in the analytics space is to help them improve or modernize their existing data warehouse. And there are several reasons why this is happening, but I think the main root cause here is that the traditional data warehousing models are not satisfying the requirements of the modern business. The promise of the warehouse always was that it will be a single place to integrate the data, all the data for the company, and provide the business insights to the user community. But we see with the advances of different external data sources, social media, real-time sources, semi-structured data, the traditional warehouses are failing in several aspects to keep up with all the changes that are happening in the modern world when it comes to data acquisition. So what's actually pushing the data warehouses to its boundaries are several things. And from data perspective, there's obviously an increased demand to ingest more and more data sources in the warehouse. And if traditionally warehouses were designed to consume flat file structures or data from other relational systems, today it's no longer the case. Today you can get data in JSON, XML, or it could be some proprietary format. It could be binary video data. It could be completely unstructured text data on which data scientists want to do some text processing. So the variety of the data sources has increased dramatically, and that's definitely pushed warehouses to kind of to the edge of their capacity in terms of how fast those data sources can be acquired. And some of them can't even be properly processed inside the warehouses. One of the use cases that we see over and over again is some kind of log file or JSON file being stored in the relational warehouse as is, not being parsed, not being broken down into entities, just being stored as text, which makes it probably impossible to apply any type of analytics on the data source. And with variety comes the volume and velocity and speed of the data that's ingested with the advance of the real-time messaging systems and what Kevin was talking about earlier. Real-time is really the backbone of the modern analytics platform, and some of the legacy warehouses can't really keep up with the speed demand. And on the other hand, there's push from users, whether analysts or business community, to get more and more insights from the warehouses. The velocity requirements for the modern warehouses, again, can span weeks now. Users want to see results today. They want to make sure that the changes to their existing reports or data marts don't take weeks to complete. So there's definitely need to get results faster. But also the types of the users that are working with the existing warehouses also changed. Data scientists are probably one of the biggest new groups that we see of data consumers. And data scientists have very specific requirements for the data. First of all, they might need way more processing power than your warehouse may give them. They also will want to use the tool sets that they're most comfortable with, which in many cases relational databases don't support. And one of the top requests that we hear from the data scientists is they want access to raw data, raw unprocessed data, because for the data scientists, the more modifications you apply to the data along the way, there's a bigger chance that you will lose some of the useful information that can be applied for machine learning. And obviously, there's automated systems that now consume data from the warehouses, whereas alerting system, personalization data that drives your website recommendation engines, all the data comes from analytics platform, and existing warehouses are just not well suited to serve all those workloads. And finally, one of the drivers that we see in terms of the modernization of the warehouse and why people think about moving away from legacy systems is the cost. So scaling the traditional warehouses is very expensive. It's usually done by vertical scaling, buying bigger machines, buying more licenses for the warehouse software. And obviously, that drives the cost of the storage, the cost of the hardware, and the cost of the licenses. So that's kind of the key factors that we see pushing people to start thinking about what are the alternatives. And from business perspective, like all the factors that I described lead to lost opportunities with the business. People can't get analysis done in time. They have very limited visibility into their KPIs. The users of the warehouse become unhappy, especially with the new groups like data scientists. They start inventing shadow IT approach where they basically roll their own environments to be able to do their jobs. So there's a whole series of consequences of not having a robust data platform that your user community will enjoy and then can use to be productive at what they do. And basically what we see is the technology landscape is changing significantly, obviously with the advent of the cloud platforms, but also the trends in open source products that are available on the market now, automation tools that help bring those components together in a fast and cost-efficient way, as well as a whole new family of visualization tools which give data users a more self-service exploration type of interfaces, where previously BI tools were mostly used to serve prepackaged dashboards and reports. Today, tools like Looker or Tableau give users a more like of exploration feel where they can go and browse the data that's available on the platform and be able to derive the results they want and not be limited or confounded to only to the reports that were built for them by the BI team. And obviously, the cloud itself brings a lot of opportunities for the analytics, and there's definite we can see definite investment going from both Google and Microsoft and Amazon when it comes to building and providing services around data processing and warehousing specifically. We see that there's a whole new set of tools, and we call them like cloud-based warehouses that are only available in the cloud and that provide a very cost-efficient way to serve and allow analytics on really vast amounts of data. And the tools include things like Amazon Redshift on AWS, or Google BigQuery on Google, or Azure Cloud Warehouse on the Microsoft platform. And that's kind of the trend that we see, that there's really no equivalent for those tools when it comes to the on-premise setup. When we're talking about setting up a BI platform on-premise, it usually has been limited to Hadoop-based platforms, but it's very different from what you can get in the cloud in terms of the speed at which you can scale, the platform, and it's really hard to beat the cost efficiency aspect of the BI cloud-based BI platform when comparing to on-premise. So we think those components, automation, open source, new type of visualization tools, and new product from cloud platforms, they demand that there will be a new approach to design and implementing your BI platform. And here at Pythian, we think we found one of the most efficient approaches to address this problem, and that is the backbone of our analytics as a service offering. So I will talk a little bit about what we think the design of these platform will look like in future, and what are the key benefits of approaching the BI platform from that perspective. Essentially, we think that the right approach to BI in today's world is to stop thinking about the warehouse as being the center of the BI universe as it has been before. In the model that we're exploring, the warehouse becomes just one of the components, and it's probably not even most of the expensive components as it used to be. So the warehouse becomes a part of the data platform, and the role of the data platform is to be able to ingest, process, and serve the data in any shape or size that it comes in. So provide a combination of really a data lake and a warehouse technology. And we're trying to address all the issues that we see with the modern warehouses, like being able to support different structures of the data, but also still be able to provide a robust SQL-driven engine on top of the data, because we know that SQL is the language of the BI. And the promise of early days Hadoop platforms was that everything will be done in MapReduce, then Spark, then there was a whole set of SQL tools built on top of those technologies. But really, in the cloud, the SQL compatibility that is provided by the platforms like Redshift or BigQuery or Azure Cloud Warehouse is way better than we have seen in Hadoop platforms in the past. So the architecture of the modern data platform, as we see it, is built on several key premises. So as I mentioned, we think that the modern BI platform should provide both the data lake and the warehouse aspects, meaning that it should be able to store the structured and unstructured data in the same place, but also should be able to provide a place where analysts can run queries on a more structured, curated data set with the very fast response times and using standard SQL tools or standard BI or data exploration tools that are available. We also believe that with the features that cloud brings, there is a huge opportunity to start separating the storage from the compute, essentially being able to store the vast amounts of data very cost efficiently using cloud storage, and only use compute for the duration of the processing that you are doing. So for example, if your ETL runs every 10 minutes, you may only run the specific processing pipelines for those 10 minutes and not require them if you're not doing this specific type of the ETL. So there's definitely cost efficiency as well as scale factor that comes into play in this model. The platform is obviously designed to be able to easy to manage with cloud. It's and the modern automation tool that I mentioned before. It's very easy to build platforms that can be provisioned in a matter of minutes. So there's no longer you don't have to wait to buy the hardware to go and wire servers in your data center, install your warehouse software. That can all be automated, and that can be rolled out on the cloud platform literally within minutes once you have provisioned the cloud subscription itself. And all that actually drives the savings in operational and development costs. And finally, one of the key considerations for the modern data platform is that you have to build for future, right? I mean, you have to make sure that the platform you're building is future-proof, and that the change in technology or change in trends won't require you to scrape the whole platform and rebuild it from ground up in a few years. And the modular design that we take here at Pythian means that each layer of the new platform, and I'll be talking about what those layers are in a moment, but each layer is completely decoupled from the next layer, meaning that you can take out and replace, let's say, ingestion tool with something else, meaning that your processing in your warehouse tools still stay the same. So this modularity is, again, driven by the fact that technology world is changing so fast, and you never know what would be the next kind of breakthrough in terms of scalability or data processing. So the designs that you have should be modular in that sense, which means that you are protected from changes. That was one of the biggest problems with the existing legacy warehouse systems, is that since the warehouse basically takes the role of your ingestion, transformation, and serving layer, there's a very tight coupling between all the tools. You can replace your warehouse and not expect a huge changes in your ETL pipeline. So we're trying to change that with the designs for the modern data platform. So here's an example of one of the cloud solutions that we provide. In this case, it's based on the Google Cloud Platform, but we have similar solutions built for Microsoft Azure and Amazon AWS. And essentially, what we're trying to do here is, this is the view of the modern cloud data platform. And what you would see is that the architecture is split into several modules. So we have the ingest module, there's a storage and processing component, there's an analytics component, and there's the data science sandbox and the visualization area. And all those components are designed and built in such a way that they are completely decoupled from each other. For example, ingestion layer doesn't really know anything about your data warehouse structure. Its role is only to reach out to the source and land data into the scalable cloud storage. On the other hand, the processing that we apply on top of the data to make sure that it's cleaned up and curated doesn't necessarily know specifically which ingestion tool is being used, because its role is only to reach out to the cloud storage, apply the processing, and send the data further down the pipeline into the analytics engine. And finally, for the analytics engine, you can see that for example, in Google Cloud Platform, we're using BigQuery as our warehouse, and the warehouse becomes just another component in the whole platform. It's no longer being the only place where all the processing or all the ingestion happens. All those layers are being completely decoupled from each other, and they're split into this separate pieces, which allows us to, first of all, make changes to each of them without the need to rebuild the whole solution from scratch, but also making the platform future-proof. Meaning, if will be a new product from Google tomorrow that will be better than BigQuery for analytics platform, it's an easy change in this architecture to move everything to that product, because the core of the processing is done elsewhere. And another big benefit of this solution is that we're trying to rely on the best of the breed open source solution, and we're using the cloud-specific platform as a service offering where there's no good or cost-efficient alternative to the open source systems. For example, we use the tools like Apache NiFi for ingestion, and we rely on Spark for our transformation layer. But for the warehouse itself, we're relying heavily on the platform as a service offering from Google, like BigQuery. And obviously, that would be Azure Cloud Warehouse or Microsoft, and Redshift for AWS. So the benefits of having a platform, a modern data platform, and not just a warehouse that kind of does all the analytics and all the processing for you, is the fact that it unlocks new possibilities and new opportunities and increases the velocity at which changes can be done to the data pipelines. Because when you want to introduce a data source, it's very easy to understand where in the pipeline changes will have to be made. For example, if your data scientist wants to explore certain new data sources, there may be no need directly to create a model for them in the warehouse yet, because they may want to go just to the storage and explore the raw files. And this makes it possible to make the changes in way faster iterations. and it unlocks the possibilities for new analytical use cases. And we have implemented a number of platforms based on this solution, and some of the best practices that we figured out over the years is that in the cloud, the cost control is essential. You need to understand how much the platform will cost. A lot of these components that are being introduced have pay-per usage type of a model, so you need to understand and be able to project the cost of the cloud platform. Since you are bringing very different data sources with different structures, data governance and data quality aspects become very important, and usually require some upfront investment to make sure that data is being aligned for your organization. And continuous monitoring and security are really big, important topics for the data platforms in the cloud, because if your data platform becomes a storage for all the enterprise data, you need to make sure that you apply very rigorous security practices. And one way that Python addresses this is using the security automation. There's a whole set of practices that allows us to perform automated checks on various existing user policies or how services communicate with each other, monitor data movements across the platform, and make sure that there's nothing out of the ordinary happening in the platform. So having things like that, we think, is essential to making sure that your platform is trusted and that businesses comfortable bringing more and more critical data into a solution like that. That is all I have. Thanks, everyone. And Steve, back to you.
Danil, some cloud providers offer database migration services. Why not just migrate your warehouse to the cloud?
Yeah, thanks for the question. It's one of the questions that we see people asking us when we're talking about data modernizations and data warehouse modernization. Indeed, a lot of cloud offerings have database migration services, meaning that it makes it easy for you to bring your relational database or warehouse into the cloud. But we think that if you are struggling with scaling up your warehouse, just bringing the warehouse as is into the cloud will not really resolve any of your challenges, because you are not using any of the elastic scalability properties of the cloud. You're not using any of the modular design approaches that I was talking about earlier, meaning that you will basically do the lift and shift approach instead of trying to rethink how your new BI stack would look like and what are the actual benefits of moving things into the cloud. So we think that just moving the warehouse into the cloud may alleviate some of the pain points with, let's say, disk size or maybe some of the performance aspects, but it doesn't unlock any of the new opportunities that come with utilizing all the potential that cloud providers and open source tools can provide this day.
Danil, how would you compare costs of an on-premise warehouse versus a cloud-based solution?
Yes, so comparing costs of the on-premise warehouse and cloud solutions is not a straightforward exercise. And I would say that what we see in the real projects is that people are usually, when we do the estimates for the cloud costs of what it would cost to migrate, let's say, the Teradata or Oracle warehouse to the cloud, usually people are shocked by how much less they're going to pay in the cloud, because the initial numbers are usually significantly low, since there's no investment in licensing costs and hardware costs. But what we also try to explain to our customers is that a lot of the costs in the cloud are driven by the usage, meaning that there will be a definite uptake in the cloud costs if you are starting to onboard more analysts, if you start to run more queries on the platform, and if you are starting to bring more and more data sources, then you would see those costs increase. So the short answer is we usually see a dramatic reduction in costs at the initial migration, since you don't have to make investments into licenses and hardware costs. But we also help our customers to project what their cloud costs would be given the type of the analysis they run, how many people they have in their organization who need access to the data, and intensity, let's say, of their analytical workload. And this way they can get a better picture of what their long-term cost would be for the cloud platforms.
Danil, what are the key challenges in migrating warehouse workloads into the cloud?
Thanks for the question. So what we see as one of the key challenges in migration projects is the fact that there's a significant effort required in converting existing business logic and ETL into something that will work, let's say, in the cloud setup. The data ingestion, data kind of mirroring use cases are easily automatable. So getting data in without transformation is usually a really straightforward exercise. But with the legacy warehouses, there could be a number of business logic rules implemented that have accumulated over the years, usually don't have any documentation attached to it. So I would say the key challenge in migration projects is being able to find people with the domain knowledge and with the knowledge of the specific business logic that has been implemented in the warehouse, so we can work with them and translate that logic into modern languages, like distributed languages like Spark, which we can run on top of the cloud data platform. So translating this existing legacy business logic into new layer of tools is probably one of the big challenges that we see in migration projects these days.